today's lesson is kind of nice. Augmented matrices. So we're talking about matrices. Matrices are a rectangular arrangement of numbers. Each number is called an element. And they're arranged in rows and columns. And the dimensions, we say, is the number of rows by the number of columns. So this here is a 2 by 3. And we put each corresponding number in front of each variable in a row. So a matrix derived from a system of linear equations is an augmented matrix. So if we look at this here, this first example, we want to arrange it so that the numbers, our variables, are in order, left or right, in alphabetical order. So we'd have x, y, z, or in this case, x, y. Now, if we notice the first equation, it's a little bit out of order because we have y before the x. Now, since they are on the same side of the equation, we can switch them. We'll put the negative 2x first, plus our y is equal to 1. Now, if they had been on opposite sides of the equal sign, we would have to add or subtract it from both sides to get them on the same side. Questions on this so far? So now to write this out, we're going to take the coefficients, the numbers in front of our variables, and then what it's equal to, and list them out. So since negative 2 is in front of x, it would go first. Since 1 is in front of y, it would go next. And then it's equal to 1. So we'd have negative 2, 1, 1. That's it for the first row. Now we can go on to the second row. X and y are in the right order, so the number, we can just put it in. And the number in front of x is 1. Number in front of y is, and it's equal to 12. Now this here is a what? So the dimensions, rows by columns. We have 1, 2 rows, and 1, 2, 3 columns. So it is a 2 by 3. That's it. Question on this here? That's literally all we're doing with this one. Are you ready for the next one? Write an augmented matrix for the system, then state the dimensions. So the second equation, we do have x, y equals a number. The top equation, we have yx equals a number. So we do need to rewrite this first equation. Now, since x and y are already on the same side, we can just switch them. Because 3y plus 4x is the same as 4x plus 3y. We just need to write them in the correct order. So our numbers going across the top would be what? 4, and then 3, and then 13. Now, since 4, 3, and 13 are all positive, we put them in positive. Our second row, 2x minus y equals 5. So the number in front of x is positive 2. The number in front of y is 1, but it would be negative 1. And then the last number is 5. Questions on this here? What are the dimensions of this matrix? It's a 2 by 3. We have 2 rows, 3 columns. We ready for the next one? Write an augmented matrix for the system, then state the dimensions. Now this middle equation, we do have both variables x and y on the same side, and they are in the correct order. The third equation, we have three variables x, y, z. They are all on the same side. They are in the correct order. They are in alphabetical order. And our number without a variable is on the right side of the equal sign. So those are good. Yes? The top one, x and y are on the left side. They are in the correct order. And then our number without a variable is on the right. Yes? But we also have the negative 2z on the right. So we can't leave it in this form. What we're going to have to do is move the z back over to the left side because we need all the variables on the left side to write it as an augmented matrix. How can we move the negative 2z? We can move it by what? Adding 2z to both sides. Because negative 2z plus 2z is 0, leaving us with our 7, the number without a variable on the right-hand side like we want it. Now when we add 2z to the left-hand side, bless you, there are no like terms, so we just add it to it. And we want z to be after y. Because again, alphabetically we file them x, y, z. So now we have our new equation in place of this one here. 3x minus 4y plus 2z is equal to 7. All right. How would we write this first row? What would we say, Allie? Yes. Darley? Go for the next one. So the next one would start off with? Almost. Because the last number would be 3, yes? Do we have a z? No. So it'd be 0. It'd be 0. And then the last row would be 2, 4, negative 1, 2. Because since that middle equation didn't have a z, we had to fill it in as 0. Got to make sense, yes? Now I'm going to come back to it, but the question is then why didn't we put zeros in for z on the previous one, yes? Did either of the two equations have a z? No, there was no z listed in either one. So we didn't fill it in because it was not there. If one of the equations has x, y, or z, all have to have it. If it's included in one, it has to be included in all of them. Since the top and bottom equation had z, the middle one has to have it as well. If it doesn't have it, it's just filled in as 0. Dimensions. So we have 3 by 4. You don't have to write this 3 and 4 here. I'm putting it there so we can visually see the 3 by 4. See the dimensions of it. Questions on augmented matrices? Let's do one last one, then we'll move on.
Jonathan Lucci come to the office. Rayleigh didn't come to the office.
So if we look at these 3 equations here, are all of them written in the correct form? Yes. So the numbers going across for the first row would be 8, negative 3, 1, 5. Then our next one would be 2, 1, 4, 2. And our last one would be 9, negative 7, negative 3, negative 6. And what would the dimensions of this matrix C be? 3 by 4. We have 3 rows and 4 columns. That's it. I need to take that slide out. We feel comfortable with these here. Don't need to see another one. All right. Now we can use these augmented matrices to solve systems of equations. Now, I'm going to look at this here.
Ravy Denton, please come to the office. Ravy Denton, please come to the office.
So what we started with is we put the number in front of x in the first column, number in front of y in the second, z in the third, and what it was equal to in the fourth. So if I rewrote out this first equation, we would have 1x plus 0y plus 0z is equal to negative 1.4. Yes? Well, do we really write out 0x and or 0y and 0z? No, this is really what? X is equal to negative 1.4. In the same case, if we look at the second row, we'd have 0x plus 1y plus 0z is equal to 5.2. And in the last one, we really just have what? Z is equal to 16. So for the system of equations, this here is the solution. And that's it. We would need to get it into this what we call reduced row epsilon form. Is what this is. Okay? Now there's 4 main steps. 1, write the augmented matrix. 2, enter it into your calculator. And 3, do the reduced row echelon form. So, we have this here. I kind of put it all there, the steps and everything right there all at once. So, flip back. Other direction. Yep. So, right there where you see the 4 pictures that look like calculator screens, yeah, the problem's right there. So as I put, yeah. One right there. Yeah. Yeah, I put it all in one so that we can see the screen and I didn't waste paper. But let's rewrite this as a system for an augmented matrix. Because we have x plus y plus z equals 2, 2x plus 3y plus z equals 3, x minus y minus 2z equals negative 6. So across the top, we'd have 1, 1, 1, 2. Then we'd have 2, 3, 1, 3. And lastly, 1, negative 1, negative 2, negative 6. Yes? Yeah, it's a little small on y'all's page. Yep. So right where your right hand is. You see it. So there's the problem. So we're writing the augmented matrix first. Okay. And it is a 3 by 4. So what you do is grab the graphing calculator and turn it on. Clear all that out. Got it turned on, yes? So the first thing we need to do is put the matrix into the calculator. So to do that, now, if you notice here where it says key press history, there's nothing listed. This will follow the keystroke. So the first thing we're going to do is hit second matrix, second x1. And that matrix button right now is lit up in red on the screen? So were you able to get to this screen here? The numbers next to the A, B, C, D, E, F, G, H, I might be different, but we do see this screen, yes? Scroll over to Edit. Edit here lets us put information into these matrices. Yep. We all got there? So we're going to edit matrix A, the first one. So go on and hit enter. Now at the very top, it's going to tell us to put the dimensions in. Well, we said this was a 3 by 4, yes? Most likely it's been typed in, but you can hit 3 and then enter, and then 4 and then enter. Enter is very helpful with this because when you hit enter, it will move it to the next spot. Now, for the most part, the calculators that y'all have won't show the entire matrice, but we're going to put it in. So I would type in 1, enter, 1, enter, 1, enter, 2, enter, 2, 3, 1, 3, 1, negative 1. So we would input the entire matrix. So we're going to enter one number at a time. One element at a time. That's you. Yeah, so hit enter. One more time. There we go. Yep. So it looks like that, because this first one for, okay. Hit enter. Yeah, because it was set to be a 3 by 41. Yeah. So as we type it in, so it'd be just 1, enter, 1, enter. Because enter just tells it to go to the next one. And then 2, I think the whole matrix is already typed in for us. We're able to get it all typed in. It was kind of nice, the class before y'all already put them into some of them. So once we get it typed in, we're going to go second quit. Second mode, second quit. Now the reason we do this, we want to get out of the edit. Because if we try to do anything else or put anything else in, it's going to put it into that matrice. So there is a lot of functions we can do and put in matrices that do help out. We don't want to do that at this point. So we quit back here. Now we're going to go second matrix. Because we need to put this matrix in a reduced row echelon form, RREF. Now to get there, we're going to go over to math. Because this here is all the operations we can do with matrices. Now, it doesn't matter which direction you scroll, you're either going to need to go up or down and find RREF. Once you find it, hit enter. And it should look something like this here, yes? Now, the next thing we're going to have to do is tell it what matrix to apply this to. Because if you just hit enter now, it's going to throw up an error. Because there is nothing that the reduced row echelon form is being applied to. So the last thing we're going to have to do is go second matrix. And this first one lets us pick a matrix to do stuff with. Now we put that matrix in matrix A, yes? The first one. Since it's already been selected, we can hit enter. And hit enter one more time. So we all have something that looks like this here, yes? Now since we put it in X, Y, Z, X was first, Y was second, Z is third, going down that last column, X, Y, Z. So negative 1, 1, 2. That is the solution for this system. That is the X, Y, Z that makes all three statements true. Questions on this here? And yeah, so everything we did in 1.5, the last section, we could have done with just this calculator. So the ordered triplet that makes all three of these equations true is -1, 1, 2. We ready to see this done again? So these here are the steps. I did put that in there for you. So let's look at this one here. So if we look at this here, the 2x plus 3y minus z equals 15. 3x minus 9y plus 9z equals -12. 4x minus 3y minus z equals 19. We have three equations with three variables. The variables are ordered x, y, z. We don't have to do anything there. So if we wrote our augmented matrix, it would be 2, 3, -1, 15. The second row would be what? 3, -9, 9, -12. And our last one would be 4, -3, -1, 19. And this matrix C here is a 3 by 4 still, yes? We're going to pull the graphing calculator up. We're going to do this again. So the first thing we're going to do is go second matrix. And then we're going to go over to edit because we need to put a new matrix E in. We got there. Hit enter. Send me my sheet of paper. So it is a 3 by 4. And then we can enter the first row. 15. And then we'd have 3, -9, 9, -12, and then 4, -3, -1, 19. Everybody got it typed in? We good? No? You're good. It takes some time to learn these things. So over to edit. So go over to. Fit into the first one. 3 by 4. Yep. And then I hit enter after each number. Yeah, because enter works very nicely with these because it'll immediately move you to the next spot. Once y'all get it typed in, second, quit. Second matrix. Over to math. Over to math, and we're going to find R, R, E, F. So, see here, 2. Okay, so 3, -1. 15, yep. Yeah, so again, one of the things to be paying attention to is minus. You can't do minus, you have to use the negatives. You get it all typed in?
Yeah.
Now what we're going to do next, after we get RREF, second matrix, and then hit enter once you got it done. So, and then 9, -12, 4, -3, -1, 19. So then second, quit, second mode. Yep, one next to it. Yep. Second matrix. Over to math. Now find RREF. It's up or down. Yes, enter. Second matrix. Enter. Yep, because that'll recall matrix A. Hit enter one more time. Hit enter one more time. Yep. And we all got 5, 1, -2. So the solution for this is 5, 1. Questions on this here? Question on anything we've done so far? All right. I know we have lots of time left. I mean, especially for me anyways. Yes. Because of pictures earlier, and especially because of the pep rally last hour, we're going to stop here.